Hello guys, welcome to Anatomy and Physiology Screencast Exam 3. Okay, so we're coming towards the end of the cycle now. We've got kind of one more smaller one to do next week, but it'll be kind of aligned to 10-mark questions. Now, some of these topics will be linked to 10-mark questions and I'll tell you when. Okay, you know the exam success cycle which I've got here. This is what you should be doing. Pausing after you've looked at the question, circle the, or kind of, write down the important piece of information, memory method, translate and extend with an example if it asks for it. Okay, so first question then, analyse the ankle joint during, I haven't put during there, so just using the information in the table. I was going to put during the movement, but I'm going to make you work out the movement. So if you look at that then, basically you've got to look at the fact that ankle is what we're looking at. What you've got to work out is what type of joint the ankle is, what are the articulating bones, what movement would cause the gastrocnemius to be the agonist, and then what's the antagonist muscle. Okay, so pause it there, see if you can work it out. Answer should be there. So remember, if you plant your toes down, okay, that will lead to the gastrocnemius contracting as the agonist. The antagonist muscle will be tibialis anterior. Remember, tibialis is attached to the tibia, anterior is back, so you've kind of front, so you've got that kind of muscle attached to the bone of the lower leg. Okay, going on to your next question then. Analyse the elbow joint using the information in the table. Okay, so basically then all I'm giving you here is flexion. Okay, so the movement is flexion. You need to determine a type of joint, articulating bones. When the elbow flexes, what's the agonist muscle? What's the antagonist muscle? This could quite easily lead into a question on explain the role of the bicep brachii on the upward and downward phase of the bicep curl. Okay, so that could quite easily happen. So this is kind of the other way it could be asked, the simpler way. So answer, if you want a quick look through that. Okay, moving on. Using a tennis serve, explain Newton's, or define, it would probably be, Newton's laws of motion. Okay, so basically what you have to be able to do is identify the laws, first up. Secondly, you need to be able to define them. Thirdly, you need to be able to kind of link it to a tennis serve. So, memory method. Okay, so basically, motion equals movement. We know that. Okay, so laws of movement. So what I want you to think now is say, right, I'm going to give you a little sentence that I use to try and help myself remember it. So you've got, I accelerate using action and reaction. Okay, so I accelerate using action and reaction. I accelerate using action and reaction. The first law is I, that is that one. So a something will remain at something or something something until a something something is something. Okay, and you go through, you see how it works. Okay, accelerate, what law does that equate to? Okay, pretty simple. Okay, and then this one, the rate of change of, and then you've got all of this stuff to try and fill in, see if you can do so. F is force. And finally, you've got action and reaction. Okay, the law is just taking out the and then can you say, pretty easy. So right, from there, okay, your answer linked to a tennis serve would be as follows. Okay, so you've got a boss. So the first law, the law of inertia, a body will remain at rest or uniform velocity until an external force is applied, e.g. your ball in a tennis serve will remain in your hand until you throw it up into the ball toss, till your hand forces it to go up. Next law, the law of acceleration. The law of acceleration proposes that the rate of change of momentum, or you could put acceleration, is directly proportional to the size of the force in the direction in which it is applied. So e.g. the harder the ball is hit, the faster the tennis serve will accelerate. Furthermore, if the ball is hit through the centre of mass, this will also help acceleration because it will go via linear motion in a straight line. So going from there, the next one, third law, action reaction. So every action has an equal and opposite reaction, e.g. the force applied by the racket to the ball, there's an equal and opposite force applied by the ball to the racket, and that what slows your tennis serve swing down. So when you hit it, if you imagine if you swung your racket through the air, okay, without a ball, your racket would fly through the air. Okay, but because your racket hits the ball, there's an equal and opposite force, okay, from the ball to the racket, which slows your racket speed down. Okay, your racket, if you watch, next time you watch a serve or watch someone serve in tennis, you will notice that the racket does not come down at the same speed from the backswing after it's hit the ball. It slows it down because the ball applies a force back onto the racket, which causes a spin. Okay, so all you need to do is just get those key bits on. Unlikely question, really, all right, but just something that I wanted to make sure I covered just in case it came up. So going on then. Next one, explain arteriosclerosis and atherosclerosis. Now this has come up once. Atherosclerosis is a 3-mark question, so you must make sure that you can have a good go at describing these and with a bit of detail. So, memory methods. What we need to do, arteriosclerosis should be changed to arteriosclerosis because that will give you the key start point to the description of arteriosclerosis, something to do with ARD, okay, or put a H in there, hard. Then go for the next bit. Then you need to say what, so what's that first bit equate to, so you're basically going, using that goes into here. Then can you tell me something else that leads to, then the effect that it has on the cardiovascular system. Then you're going for atherosclerosis, so instead of saying athero, okay, we're going to put F in front of the AT, which will give us fat, okay, so then we're going to use that word fat to go to start here. What is atherosclerosis? Well, we need fat here, okay, so then we need to say what does that mean, what else happens, and then what effect does it have on your kind of cardiovascular system. So translated, arteriosclerosis then is the arteriosclerosis. It's the hardening of the coronary artery wall, leading to a reduced elasticity of the coronary artery. This then reduces the ability to vasodilate, vasoconstrict, thus leading to the kind of inability to regulate blood pressure. And the key cause is smoking. If you're struggling and you just think, do I need to have something else, then you're going on to atherosclerosis. So atherosclerosis equals fatherosclerosis. Take the first 3 letters of fatherosclerosis, you get fat. There is a build-up of fatty deposits around the coronary artery. Well, you only need 1, fatty deposits is fine. This reduces the size of the internal lumen, so the space in which, inside the artery, which the blood has to travel. As a result of this, you will get an increase in blood pressure. You'll also have an increased chance of a blood clot, okay, which will then obviously is what would lead to a myocardial infarction or a heart attack. This is caused particularly by a high cholesterol diet, which obviously then transpires that the cholesterol will stick to the wall or fatty deposits. Okay, moving on. Next one, explain how a period of aerobic exercise can prevent the onset of coronary heart disease. Okay, so as soon as we're talking about aerobic exercise and how does it prevent the onset of coronary heart disease, we have a specific way of remembering these. Okay, so basically you're using your memory hook. So these are your even numbers. So soup turns to supermarket. Can you remember the supermarket? And can you remember how you abbreviate the supermarket to get what decreases, and then what causes that decrease to happen? It's the opposite type of lipoprotein. You can take it from there. 4, reward. The reward you're thinking about is a trophy. When you get a trophy, you get excited. There's another word for that. Okay, can you then put that into a term and try and link it to coronary heart disease where possible? 6, anorexic. If you're anorexic, you're thin. You have something in your cardiovascular system thins. Can you tell me what that is and what the correct physiological term for it is? How does it prevent coronary heart disease? 6, flick knife. If you stab someone, there'll be blood. Blood is red blood cells. What happens to them as a result of aerobic exercise? That's the only dodgy one there, because that's not necessarily linked to coronary heart disease, but you can try and make it link. Then from there, okay, 8, mate. Okay, so if you talk about a mate, another word for mate is a peer. Okay, so peer, if a peer tells you to do something you don't want to do, e.g. smoke, okay, e.g. drink, you should do it, you'll be really cool. That is applying peer something. That word will then link to a word associated with coronary heart disease or kind of the cardiovascular system, and the resting value of this could be reduced, okay, or maybe, it could be healthy. Could you give the resting value? Okay, and it could also prevent the onset of a high value of this, which is another term, which basically will be 140 over 90 mmHg. Okay, how does that translate then? It translates to this, if you want to just check that you've got that right and move it on. So I've tried to go through the memory methods for those who haven't done them in class yet, so you can kind of see how I'd work with those. Obviously, Lidl was a supermarket, abbreviated to LDL. Okay, there's not many Lidls in Worcester, so there's a decreased LDL due to an increase in HDLs. Okay, they act as scavengers, chip away at fatty deposits. You can see this, you can read this. have a look through it. If you want help with the memory hooks, that's fine. Moving on then, next question. Explain how a period of aerobic exercise can lead to respiratory adaptations or can affect the respiratory system. Again, we have memory hooks for these. These are our odd numbers. We start with 9, remember? So we've got 9, dine. So dine, you dine in a restaurant. If you're in a restaurant, you eat. The food you're going to eat is ravioli. Ravioli rhymes with alveoli, but you don't like the alveoli. You want more. It's bigger. You want it bigger. So talk about what happens there. Number 1 is home run. Number 1, home run. Where do you score a home run? Baseball. Okay, what do you wear when you're playing baseball? A baseball cap. Cap is the key link there. Something happens. It happens at 2 places. You have to say how it happens at 2 places and how it allows gases to move more efficiently. Then you got number 3, C. All right, if you're at the sea, you will see waves. The biggest wave of all that you can see is a tidal wave. Tidal wave should link you to a lung volume, and then you should be able to talk about another 2 lung volumes. Number 5, rhymes with drive. If you drive a car and you crash it, you take it to the mechanics. The mechanics is the key link because there'll be an increased efficiency of the mechanics of something. Can you talk about the components of that which allow it to more air and increased depth and rate of breathing? Then the net effect of those is an increased VO2 max, delayed obla, which prevents fatigue and allows increased aerobic performance. So going on from there then, a translation, if you want to have a quick look through those, that's what you should come to. Okay, and moving on from there then, last question. Identify how carbon dioxide is carried in the blood. 2 ways. Okay, so there's 2 ways you could do it. Well, there's 3, but you could get 2 marks for it. And then explain how more carbon dioxide is diffused into the alveoli during exercise. Okay, it's a really important thing to say. Now, key things you're looking at for this are as follows. So CO2 plus something equals something. And then the other way it's carried, well, they both carried exactly the same way as oxygen is, but you've just got a slight different slant on it because carbon dioxide binds with something to form the combination of the 2, but also it's carried in something else in the blood the same as oxygen is. There is a third way, which is carbonic acid, which I haven't put on here just so I don't want to confuse people. Then, because the next part of the question is gaseous exchange. Okay, so it's looking about how more carbon dioxide is diffused into the alveoli during exercise. So we're talking about blood and alveoli. The key thing we're focusing on here is we have to exaggerate because it's exercise. So when we get down to here and here, we must make sure that we are kind of really exaggerating stuff. I'll explain that as we move through. Remember, anything to do with diffusion other than oxygen diffusion at the muscle tissue during exercise, muscle X, Mexican, that's the only time we use the Dr. Taco. Everything else is GASP-DD. What does GASP-DD stand for then? Firstly, we're looking at the gas the question's asking about, carbon dioxide. Then we're looking at the area. Is it alveoli or is it muscle? Alveoli. Then we talk about the special rule. Now the special rule refers to kind of diffusion. Where do gases always move? So carbon dioxide moves from an area of what to an area of what. Then we'll talk about where the partial pressure is high, where the partial pressure is low, but because it's exercise we have to exaggerate that point. Then we're moving on to the fact that if that is the case and you've got a higher of some carbon dioxide one place and a lower partial pressure carbon dioxide the other place, that causes a CO2 diffusion gradient, therefore a steeper diffusion gradient because of the fact it's exercise, and then that leads to that gas diffusing faster. Put into kind of correct terminology, you can have a read through that. So they're your key bits. Have a read through it and see what you think, if that makes sense to you. Last question, I think, or that might be it. Yes, that's it. Okay, so if you just have a look through that, GASP-DD, so whenever you get that on that, you always just do your first 2 questions of gas or area. So which gas is the question asking for, which area. From that, you then be able to work out where the high pressure is, where the low pressure is. Okay, thank you.